session from today onwards, I think we're shifting our gears primarily towards Kubernetes. Um, that is because I think we have a lot of interest in this group, and we also discussed multiple times in the past about Kubernetes, but we never got a chance to go deep dive. But I think let's start with based on the request from multiple people. I mean, in the last session, so yeah, there's a good interest that was showed on Kubernetes. So we thought let's start with Kubernetes. And the idea is initially I was thinking to start just give an overview about Kubernetes and at a high level uh, give some brief about it. But I thought anyway GK is also part of. I mean Kubernetes is there in every cloud provider. If you know one provider, how it is implemented it's exactly more or less similar. Just minor changes will be there, but more or less the concepts remain the same because it's completely an open source solution. There will be minor increments that you need to know from each cloud provider. But other than that, like the base concept of Kubernetes will remain the same. So, but before going to Kubernetes, I think there are some prerequisites that we need to know. Because these are some basic building blocks, which is container. Because the Kubernetes is orchestration of containers. So first we need to understand what is container. So probably will not spend much time on container because container itself is a bigger topic. But I thought I will give some brief so that you get some context. But I think the more is deep dive into the Kubernetes. So probably yeah, let's see how much time we have based on that. Probably if not, we can go deep into the Kubernetes in the next sessions also. But yeah, today let's start with the basic building blocks, which is container. But I think most of you would have known what is container by now, but I'm just giving the context. So container is basically the standardized packaging model where you can package all your libraries or binaries and you can ship it with all the entire bundle so that it can run the same way in whatever environment that we discuss. So if you look at the common problems before containers came, right? I think if you take any, I mean, if you take a situation where if you're talking about a Java application or a .NET application or any Python application, the before container came into picture, I think we take the binary, which will be in Java it will be a jar file or a war file, or and also in the .NET it is an exe. So likewise, we'll take these binaries and we generally deploy it into our staging environment or production environment, and that's when we run those binaries and see whether output is coming. But the problem with this binaries is that this binaries will not come with runtime inbuilt. So that way, the binary that was built in one machine, it can sometimes behave a bit differently when it is put in a different machine because the runtime is not part of it. So so yeah, we have seen the cases in the past where yeah, we always discuss with our operations team saying, hey, this jar was working in my machine, why it is not working in staging or QA environment or production environment. We all gone through those phases. So I think the way all is common, all because of runtime is not there part of your library. We have all these problems. So now container in the new world it solves that problem in a way that it along with your bundle of your library, which is your jar file or a exe. So it will also associate your runtime and also the system tools which are required for that, and system libraries and also settings. So all put together is what is container is. So that way when you have runtime and the system libraries along with it, so the binary will work the same way or the container will work the same way in irrespective of whatever be the environment. Either it could be Linux or Windows or Mac, the container will behave the same way. So that is what the beauty of container is, and how why it is become so popular just because it has a lot of advantages compared to a VM. I think we'll discuss how is it different from a virtual machine. But before that, if you understand what container architecture or how this stack in a container will look like, the basic building block is always an infrastructure. If you see the diagram, it's always an infrastructure. So, and there is an operating system on top. And on top of this, you have something called container engine. So, so this container engine is what is doing that magic of talking to, when you run some binaries, it talks to the underlying operating system and the infrastructure, and get the library executed. So, so if you look at here, all your libraries that you're building, it's application one, and the libraries or dependencies required for application one are bundled as one container. Similarly, application 2 and binaries for it, and application 3 and binaries for it. So all three are now at this point independent, but they, when you run this this container, it basically invokes your container engine, and container engine will get the required compute and storage associated. In the compute and storage in any machine that you run, for example, it could be your laptop, or somewhere in the cloud. So the operating system communication will be all managed by this container engine. So I mean, as a developer, we need not know, because this is already developed and given by proper container engines. So you don't need to know the intricacies of how this container engine is talking to the underlying operating system or infrastructure, because it's all taken care. What you need to know as a developer is how to build or how to package it, how to package your binaries into container images, and how to deploy it. So these are two things that you need to know. But the rest of it is all managed by the container engine. So that's the background of what is container. And there are a lot of popular container engines that are available in the market. But a very popular one is Docker, which is from Docker Inc. But apart from Docker, there are a lot of other Docker engines are also there, which is Containerd, which is again managed by CNCF, which is Kubernetes. It's container. It's a cloud native computing foundation. It's an open source foundation which manages all the open source softwares. So it is managed by CNCF. Creo is also, now Docker is definitely popular, but next to Docker, if you look at the Containerd and Creo are getting popular because they are more compliant to OCI standards, which is Open Container Initiative standards. So Docker has some limitations in that. So slowly Docker is coming down. And for example, even the Kubernetes embraced Docker, but slowly even Kubernetes is also moving towards OCI compliant container engines. When I say OCI compliant container engines, there is this open standard format that is agreed for all the container engines, and so that all these container engines should follow that specification. So in that way, Docker is not compliant to that specification. So yeah, I think but still the Docker is still definitely the popular container engines in the market. But I think these are all upcoming container engines which are getting popular: Containerd and Creo. And for Windows, which is primarily the Microsoft, Microsoft has, all this, if you look at, they're all started with Linux as a source of operating system. But initially they were not supporting Windows, but later Docker is now collaborated with Microsoft, and Docker is also supported on Windows. But it is Containerd and Creo are still completely Linux compliant servers, Linux compliant container engines. But Microsoft, apart from Docker, Microsoft came with their own container engine, which is Hyper-V containers, and also the very old container engines or LXC. LXC stands for Linux containers. So this is the age-old container engine. Before Docker even came, LXC was there. So this Docker concept, or this container engine concept, is not new. It was there quite some time, but just that Docker made it so popular because of associating a runtime along with the binary. So that was a trick that clicked, and yeah, soon a lot of bandwagon towards Docker, and it becomes so popular. But as such, Docker is an open source. Docker engine as such is an open source solution. But Docker also has an enterprise version, which is maintained by Docker Inc. So of course, Docker has two sides. One is open source, which is anyone can use it, but also there's an enterprise version of it also. Yes. So that's about containers. But yeah, before I think it is very basic. Then if you have to remember what is container, it's just a portable packaging software, just like a jar. A replacement of in Java or in Microsoft would say replacement of exe. It's just a portable packaging software. What it has a bundle of code plus runtime plus system tools and libraries and settings. So that concludes a container, and we can take this container and build it anywhere. So, any questions here?
Yeah, very nicely explained there. Thank you, Shyam. It's a
Yeah.
great, clear understanding.
Yeah,
Thank you.
Shyam,
Yes.
Container ID is also having the enterprise edition, or it's totally a freeware?
The container is a concept. Container is just a portable packaging software. Okay, but this container concept is implemented by various container engines. So you need to pick one engine. Probably Docker is most popular. So you can pick Docker if you pick Docker as a container engine. I will give a demo on how to generate a Docker software, packaging software where you can use it and deploy it. So then you need to use this to build a library. So build your, uh, your software.
Okay. Yeah. Okay. Thanks.
Okay. So yeah, I mean, one popular thing is that or myth I would say in the market is when someone says container, they associate with Docker. So yeah, just keep this in mind. Docker is not only container engine. We have other container engines are also available, and Docker is become so popular. But when someone says container, Docker is just one of the container engines. But there are container D, Cryo, others are also available. Yeah. Okay. So let's.
yeah,
Yeah.
Jnanesh, you have some slides around the containers, right? Sometime before you had something around that, right?
Yeah, I was kind of trying to do something around that. Yeah, I may have to dig it up, but yeah, not.
Yeah. So if you have that also, you could second with what Sham said. So
Mhm.
that just to reiterate, so this is the first you have to get the grip on this. Once you get the grip on the containerization, then Kubernetes is just an orchestration sitting around this. Um, so as long as the biggest challenge is like the VMs once it came, right? It revolutionized the EC2, for example. That is what set the trend, and auto scaling group, and the whole 9 yards of um, based on if a load it can scale up and down kind of a thing. It was not just in the paper, it was really working for any enterprise. So the cloud revolutionized that. This concept is, instead of taking on the VM level, because VM is a machine, even though you have all those scale up and scale down on the VM, you could have only so much VMs because VM is expensive. Still, it's expensive. Cloud reduce the price. Still, um, it has the it needs to have so much the landscape to sit. When you put it in a data center, right? You have to make sure if the size of the machine is so huge, that depends on the heat capacity what it releases. There are so many things to be done to make sure your machine is properly installed, and the next machine should not sit next to it because of the heat transmission also. So this particular thing is trying to say, okay, you bought all those concepts on the scale up and scale down, but now I am trying to do it on a smaller scale. on the container level, so that when you define your runtime, so like what Sham said, right? Once you guys came out with what your software really needs, so it basically tells one thing: it works on me and not works for you, because each one has their own class path and the operating system dependency, right? We have seen it for the last 25 years. That is the norm of the IT world, right? But this is saying that the Docker file should have self-composed, and it can able to get what it needs, and it can run anywhere as long as you define that properly. And also you could define what kind of memory it needs and what kind of a CPU it needs. So this is the very important thing. Like, containerization takes your CPU and memory requirements down to the container level than from the VM level, so that the scaling happening on the containers level, to better utilize the number of applications sitting within the VM. Previously, you know what? Since VM is so cheap, okay, I can not so cheap, I would say so easy to do. I'll clone it, I will clone it, but you'll have so many of machines running because of cloning of the VMs. But now that problem is going away, saying that you don't need to have the whole VM to make it work. You just need the containers, and the container itself can scale and up and down. So, Jnani, if you have anything around that, bring that
Yeah.
also, so that
Yeah.
before we go to Kubernetes, it will pave the foundation.
Yeah. So one thing actually I would like to say, right? Like container solves a problem, right? Like so typical. Just I think maybe Sham already iterated this, but just telling you, in a typical development world, you develop an application, it runs on your machine, it's fine. Once you give it to the other side, like QA or somebody, it may not work. So that kind of variability, right? Like that containerization removes. Actually, basically, what you're doing is, along with developing your application, you're pretty much giving a small VM saying, okay, here is my application. And when the other person runs it, it is the same environment that is running. So there shouldn't be any variability at all. So it should work ideally. It shouldn't cause any things. Okay, right? So that is it used to be called, like in Windows, we used to have something called DLL health. Like that's other problem that we were talking about, right? Like so you have one application, Oracle version 7, and then you have your application comes with Oracle 8 or 10, right? Like, and then your the compatibility is broken. Actually, once you need 8 and then you have 7, the DLLs will collide and it will not do it. This one clearly segments it. If your application needs Oracle 10, that will be in your container. Yeah. So for development world, container is the new server that you have. That's it. You have your own server. Nobody can question anything in that. You define how it is going to be, what your requirements you need, and that's it. So that's what gets carried over, right? So that has, container is the concept. That concept means abstracts that, right? Basically, anybody who wants to run an application, it creates the ecosystem. It's like a Trisangu Sorgam, right? Like you have you have everything you need. Like it's not really that thing. Okay, so that is the main thing that you need to remember. And the one, I think I don't want to get ahead. Like I think next Sham has other slides, but I can bring in maybe next week. I think I'll try to bring in the slides that I had, like a couple of slides that I had. Then we'll talk about it.
Yeah.
That
So only
helps
one more point
explain
is,
things.
one more point is isolation, right? Even though you got the container is your mini VM, even though it's a mini VM, still it's an isolated VM. So others cannot touch what you have
Correct.
inside. That is
That's
one
what
of
I
the
said.
problems.
It's your own heaven, actually, right? Like so.
Yeah.
Basically, you have everything that you need. You can do whatever you want. Nobody will question. And you are the only guy. Like I am the center of the universe. That's kind of the approach. So
It's an immutable, right? Is it? It's an
no,
immutable thing.
it's not immutable. It is mutable. But I am just saying, like it's like this is like going back to the operating system level, like back in the Windows, right? Like where Windows 3.1, we all shared our own memory, right? Like the same common memory, and somebody writes, and then the another application writes to it, you would corrupt it. So then they came up with this new solution saying like each process that comes up has its own memory stack space. The operating system kind of does the magic, saying, okay, your memory is this, the other processor's memory is this, right? So that is the kind of evolution. It's like from that, right? If you start doing that, from that memory level to we have really gone into the actual server level, like or like the machine level, right? Like so basically when you are inside a container, you can think as if you are the only one who's going to be in that container using that machine, and the operating system and the container engine kind of pretty much virtualizes everything for you, and you don't have to worry about anybody else out there. That's the concept. That's a very good concept, but yeah. So, and I think Sham can go on. I think I don't want to get ahead of the.
Yeah, sure. I mean, anytime feel free to add. I mean, this is all good to add more wherever we feel. Yeah.
No. I know you have prepared all these slides. Actually, I just wanted to give a brief overview. But don't want to get into the real what you call. You may have more slides in a progression. I don't want to disturb that flow.
Okay. Good. Yes. So just think about this diagram. I mean, we may not see these three layers mostly in sense like, for example, let's assume I want to run Docker on my laptop. I mean, I'm starting Docker because it's become so popular, popular container engine. But let's say if I'm installing Docker on my laptop, my infrastructure is my laptop in this case, and my laptop has a Windows operating system, and the Docker is already installed. So the container engine is already in place in my laptop because of the Docker installation. So these three are already available. So what I need to do is, let's say I have a Java application or a .NET application. So this is my app. Let's say hello world. Let's talk about Java app. Okay, I have a Java app. This Java app is already having a binary and a library, like a jar file or which is Microsoft when it's a DLL or exe. So I have those. Now what I do is I have a jar. Now I can take this jar and containerize it so that I get a container image. So jar is equal to container image. I mean, it's not exactly equal, but I think you can consider that to start with. You can think that way. So earlier we used to give jars for deployment, but now in the container world we say we give container images to the deployment. So the deployment team, they will ask you where is your code. So what you need to give them is container image, and they will deploy this container image on the server. So it's the same. I mean, the older days we give jars or libraries, exes. Now it is container image is what you give. So that's the only difference. But the difference is that the olden days, the runtime is not part of it. So the jar that you built on your machine may or may not work in the server. But when you build the same code with container, since it is also having binary plus runtime associated in the same library, the code will work the same way in server also. In whatever servers you take, either the server could be a Linux based or it could be Windows based or Mac based, it will work the same way. Even though you let's say you developed on Windows, you build the image on Windows, but you give it to a Linux operating system where staging or production is hosted on Linux, it will work because the runtime is also part of the image. So yeah, so that is the only thing that you need to. So what is different is instead of giving jar, nowadays you're giving container image. That is the only difference. But rest of it on the server, the prerequisite is when someone is deploying this image on the server, they also should have a container engine installed, like Docker should be installed on that machine. So that is the only prerequisite. So, Docker is also has to be installed on developer machine. Docker also has to be installed on the production server or whatever, or your staging server, wherever you're deploying the code. So because only Docker can understand, or your container engine only can understand the container image that you are giving. Yeah. So that is background. I think with that, let's move on. I think we just discussed about the virtual machine, right? So virtual machine also does the same thing, right? More or less, we give the jar files, and with the jar will be deployed in some virtual machine, right? How is that different compared to the container world, right? So the difference is there are, I mean, mostly in terms of the number of layers that we have. The container will have lesser layers compared to a virtual machine. So if you take virtual machine, so typically there is an infrastructure. There's a very big infrastructure that will be there. Let's say let's talk about the cloud scenario where, let's say, you're going to AWS and you're creating you're spinning up a virtual machine in EC2, right? So, but behind the scenes, AWS would have bought a very big infrastructure, and they would have installed hypervisor on top of it, so that you get a smaller chunks of machines on top of on the big infrastructure. So you get a machine 1, machine 2, machine 3, or I'm just OS 1, OS 2, OS 3. So in the same machine or infrastructure, using the hypervisor software, you could install a guest OS, and on top of which your application binaries could be installed. Same thing. I mean, this on top of hypervisor virtual machine 1. Let's say we have 3 virtual machines. One virtual machine, the hypervisor could be a Linux based or a Windows based or a Mac based. It could be anything. But even underlying infrastructure also could be either Windows or Linux based infrastructure. But this operating system that the guest OS that you're installing, it need not be a Linux. It could be even, let's say, Windows, or it could be some other Mac also. So all the magic of having multiple OS under a bigger OS is what is done by this hypervisor. So it shares all the runtime, all the operating system calls, or the resources required to install various virtual machines inside a bigger virtual machine. So all is all done by this magic hypervisor. So so that is the world probably, yeah, 5 years back. I mean, this hypervisor has become so popular, and everyone started using hypervisor, and they installed various guest OS. I mean, mostly the machine that mostly you use in your organization, the virtual machines that you use in your organization. Mostly it will be, if it is Linux, it will be mostly KVM or some hypervisor software will be installed, and you get one operating system where you connect to that operating system and deploy your code. For some other project B, so they will create one more VM, and they give the user ID passwords for those, and they will connect. The project B will connect to this VM. Project C will connect to this VM, and they deploy their code. So this is how the world was before. But if you see in this world, there are a lot of extra resources. So hypervisor itself is a bigger software it's a heavy software that you need to install, and it consumes a lot of resources. And on top of this, we have OS. OS is one of the most consuming resource. Like OS inside of OS is the most consuming resource. So we have a lot of OS on top of hypervisor. So OS itself is consuming a lot of resources. On top of which you have your applications, right? So guest OS and hypervisor, these two are eating most of your resources that you have on top of your infrastructure. But when you move to the container world on the right hand side, so this hypervisor is not required. So we are eliminating the bigger chunk of resource consumption in this stack, right? Hypervisor itself is not required. So we are saving a lot on the resources there. That is one. Then you also don't need the guest OS. That is also taken away. because the container engine can support various operating systems. So behind the scenes. So you're taking away the guest OS also. So that way, the bigger chunks of this guest OS and hypervisor is taken away. So which means you save a lot on the resources, and also it is like it is lighter in size compared to a code that is deployed on virtual machine. So because of these advantages, I think the container becomes so popular. Now, what you saw from the diagram, it is same diagram. I think whatever you saw here, it is same. The infrastructure and then operating system and then container engine, and we have apps on top. So we are taking out the guest OS and hypervisor, which are the two bigger chunk of resource consuming layers in this compared to VM. So that way, the advantage that we get in container is is less overhead, because first of all we are moving out of hypervisor. So hypervisor is not there at all in this layer. Right? So and also since it is having the lesser layers, so compared to a VM, it can boot very fast. So a container can boot very fast compared to a VM. I mean, this not a bigger difference because it will be just a couple of minutes more, but still that matters, especially when multiple softwares are running on or containers are running. It matters. The boot time matters. So you get a very fast boot time compared to VM in containers. And I think we just discussed this increased portability. So because the VM, the container image that you're generating, we saw in this previously, the container image that we generate, it comes with code and runtime plus system dependencies. So that way, the code will work the same way, whether you create the image on Windows or somewhere else, it will work the same way in every environment. So that is one other advantage that we get. Another thing is isolation. So here, the container engine ensures that all the resources that are being utilized by the specific container image are dedicated, and it is provided an equal share, just like any other binaries that are deployed on the same container engine. So it shares, it's sharing all the operating system and infrastructure, but it always isolates the CPU and memory, whatever is required for every container. So that way, everyone will get an equal share of the resources, and that is all managed by the container engine. So that way you get the isolation boundary for your app. So that way, when especially when your same operating system or resources are being shared, so this equal share and isolation is very, very important. And next is rapid scalability. Of course, you can scale this up very quickly. Like we discussed about the scalability, you can quickly create multiple instances of container image on the machine. So that's because the runtime, because of less overhead, it quickly spins up with more scale values compared to a VM. And of course, lighter in size, we saw that because the layers are less. And also the code reusability. This code reusability is like every application is a container image, so you can reuse that container image. For example, you have Ubuntu container image, so you create a Ubuntu container image, and you can put it in a common place. Generally, it's called container registry. So you put it like Docker Hub is one of the popular container registry. So you can push your container image into a place where others can reuse it. So so the Docker Hub is a public repository of your containers. You can use that, but if you want, you don't want to put it in public, then you can use your own container registry. Like within your organization, you can create your own Docker Hub equivalent container registry, private repository you can use, and you can post all your container images in one place. So that way, the code is reused in the form of images, container images. And next is cheaper. So cost-wise, it is very less, because let's assume, take this concept, Docker. If you take Docker as a container engine, Docker is free, right? So of course, the enterprise version will come with the cost, but mostly it is open source. It is free. And let's say, but if you take virtual machine, the virtual machine is tied back to again the vendor that you use, and mostly the VMware is the most popular virtual machine. But if you take vSphere, which is their enterprise version of VM, which all the cloud providers have tie up with VMware just because VMware is so popular in this world. So the vSphere is the licensing cost is very huge. I mean, just there is enterprise version, it costs around 120 US dollars per month. So which is per month is like it's too much cost, right? So yeah. So but here on the other world, even though if you take the enterprise version of it, still it is cheaper. The container engine, even though if you're not looking for an open source, but if you're looking for an enterprise version of Docker, still it is cheaper compared to the VM. So yeah, so that is the advantages that you get. So summary, container has less layers. That way it has a lot of advantages, especially it is taking out the guest OS and hypervisor, which are the two critical components, which is that way your layers are less. So because of the layers are less, you get a lot of advantages like fast boot time, portability, isolation, scalability, lighter size, and reusability cheaper. So these are the advantages of container. So I think the reason why all the cloud providers they initially start with all virtual machines, but soon this Docker came and everyone started giving a container equivalent solution also as their offering. Just because it has become so popular and everyone started embracing containers very quickly. So because of these advantages that they have, I think most
So
of
the
you.
hypervisor. So Sham, the hypervisor, right?
Yeah.
The VMware is one of the hypervisor, right? What are all the other hypervisors in the market?
Yeah, KVM is one which is most popular in the Linux side, and Windows is Hyper-V.
There is Zen too. Zen is
Zen is also
other.
there. Yeah, Zen is also a popular Hyper-V.
So is that market going away now because of this eventually?
I mean,
No,
the
that
VM
will
has the
always
other
be there.
advantages. Probably yeah, you can go ahead.
No. What I'm saying is like the nothing is going away, right? Like so. So for example, right, like container, right? It is a container, but you could run the container inside a virtual machine, right? So in fact, in RBC, right, like for development and or like non-development thing, they don't give you physical machines anymore. So what they do is they give you bunch of virtual machines, and on top of it you run container engine, and then you put the container in there. So this way they don't spend new hardware. They're basically giving you virtual machine is to reduce the hardware footprint on your data center, and then virtual machines are still there. But VMware is the commercial version that they are. I mean, it's like they have a big support, and pretty much like the hypervisor they said, right? Like on one machine you could take one bare hardware, you could put the VMware EKS or I don't know which one it is. So then you can install Windows on it, Linux on it, anything, any guest OS, right? So that is the thing. So Zen is another hypervisor that sits on top, and you can start installing other OS. So it's not like one is complementing the other, right? Like it's not like VM is going away or this is going away. It's just I see it as what is like container. It's a new way of charging less to application. I mean, or the firms actually. Basically, you are reducing the. You are not asking for a VM, right? VM is a lot of resources. With a single container application that you are running, it's even lesser resources, so I can charge you less, so your cost is going to be much lesser. So that is a win-win situation for cloud, I think, cloud providers. So I don't think VM is going away.
Yeah, I mean, just to give a small analogy, right? I think if you can imagine that you are a cloud provider, okay? So, or let's say you are an enterprise which you're running a private cloud, okay? So this infrastructure that we're talking about, right? So let's imagine you're AWS, and AWS will buy infrastructure, which is they buy very big hardware. I'm just giving a random number, but yeah, let's say some 300 GB TB hard disk and also some very big I'm just putting some numbers. So 10x power of CPU. So very big machine. So very big machine that they purchased it. So this comes with a cost. So but the advantage that the VM world can. So what they do is they're very big hardware that they buy. And now on top of this bigger hardware, it could be a Windows or a Linux operating system. So let's assume it is Windows. So Windows, generally Windows means Windows Server, because the Windows Server is what will be installed on this machine. It is Linux and same. So the Linux, whatever, a lot of flavors on Linux is there, but yeah, but whatever it is, you need a server version, not a client version. The server version is what will be installed on this server. So on top of this, they will install this hypervisor. So the hypervisor is the next layer. So on this very big machine, they install this hypervisor. This hypervisor, in Windows, it is Hyper-V. For Linux, the most popular is Zen and KVM. So these two are most popular Linux hypervisors. But of course, VMware also has a vSphere, which is another component from VMware. So these are all various hypervisor softwares that sit on top of this. So now this bigger hardware is now, it can now split because of this hypervisor, it can split. So let's say there are 3 projects in the organization, which are popular projects. So project A requests the infrastructure team to give me a VM. So what this infrastructure person, what they will do is they have a bigger hardware and they have installed hypervisor. Now they will give create a VM with, let's say, I'm just giving some random number, 100 TB. So we have 300 TB, so they're splitting that to 100 TB. And project B, same thing. They create another VM, 100 TB. So they're splitting that bigger space into smaller spaces, and they're giving a VM. And the advantage here is this VM, this project A VM can have a Linux operating system. This can have a Windows operating system. Our project C could be a Mac operating system. So it is possible. So basically you're splitting this 300 TB, let's say Windows hardware or Linux hardware. On top of that, you are creating different operating systems on top of Windows or Linux. So that magic of converting that Windows into multiple operating systems, these are all called guest OS. So what we see here is guest OS. So that beauty of converting one bigger infrastructure into smaller infrastructures is what this hypervisor is doing, that magic. But the problem here is each individual OS is having a lot of resources, and here also hypervisor also eats up a lot of resources. So very resource heavy software. So it's out of 300 TB. I'm just giving, but ideally you will not get. There will be software that will be eaten away by hypervisor. Let's say just giving a random number, but I think let's say 10 TB of space is eaten away by this hypervisor, and so eventually you get only 290 TB. 290 TB is what has to be split, and there's a OS that is installed on top of that. So even if you give 100 TB for each, but still this OS is there, so that eventually a developer will get only 90 TB inside, not the real 100 TB, because the operating system takes some resources. So eventually the bigger hardware is eaten up by the smaller component from hypervisor, as smaller component from the respective guest OS, which is eventually reducing your utilization of the resources. So that is a drawback in the virtual machine world. But whereas these two bigger chunks are replaced with a smaller chunk, which is container engine. So that is when it directly talks with your final operating system that we have here. So that way you are taking out these two bigger chunks so that you get full utilization or maximum utilization of the resources on this infrastructure. Yeah, that is what container is trying to embrace. But to answer the question, are virtual machines moving away? No. The reason being, there's still you need that. I mean, most of the organizations now they are stopping creating multiple virtual machines and they're consolidating with one bigger virtual machine. And inside that, you could create a Docker engine, a container engine, and you can use that for so that you get complete resource of that VM. So, but some of these VMs could be reduced, but still the VM has other advantages which containers couldn't offer. So VM still will be there around the world, but probably they will consolidate or they will come down in terms of numbers. Um, Probably they will buy one bigger infrastructure and probably create. Earlier they were creating hundreds of VMs in it, but probably they will reduce that to probably 2 or less than 10. Probably, yeah. So and they will install Docker on top of that, and yeah, they will start using it. So yeah, but the VM is not going away, but I think the usage will come down. So that is, or the number of instances or licenses will come down for sure. Any questions? That is a very good questions. I think good to know the basics first. But we are spending a lot of time here, but it's really, really important. Yes, any questions here? Okay, let's move on. So now let's understand the popular Docker. Again, there are other containers also there, but I think Docker is the most popular one. So probably let's look at Docker. So if I understand what is Docker, Docker is is primarily a company which is launched in 2013, and they open sourced the magic called Docker engine. So the Docker engine is what this container engine is. So basically basically you can install, if let's say your laptop you can install this Docker engine, Docker software, then which means your Docker engine is what is installed on your laptop. Then on top of that, you use some commands to talk to this Docker engine. So they created this Docker engine and they open sourced it. So again, the same. What is Docker? Again, Docker is same like what the definition of container that we saw. It packages software and it can run on any operating system, Linux, Windows, Mac, any computer it can operate, and works the same way in on-premise, cloud, public cloud, or private cloud. So yeah, it doesn't matter where the machine is. So it works the same way. It works in your machine. It works the same way in public cloud, private cloud, or on-premise machine. It works the same way. So the popular Docker commands that we need to know. But I think before that, probably I will tell what is required for you to install Docker first. I think mostly I installed already Docker on my laptop. I'm just using laptop as my software. So Docker is already running on my machine. For Windows there are various Docker. So what you do is Docker on Windows. If you type, I mean, mine is Windows, but you can install Linux version also. But Docker desktop is something that you need to install on your laptop. So install Docker desktop on Windows. This is a Windows-based Docker software. That is what is you need to install on your machine. It's a exe that you need to run, download, and run it. So I already installed it. So that's why Docker software is the Docker desktop. Windows version is called Docker desktop. So that's why the Docker desktop is running. So that is already installed on my machine. So with this, what you can do is I just created a small set of instructions. So if Docker is already installed on your machine, I think let's move to this practicals. Docker hyphen version. So if Docker is already installed, you get some Docker version, which is like it's already installed on my laptop. So now Docker is running on my laptop. So what it means is in this architecture back. So you have my laptop is playing as infrastructure, and my laptop is already having Windows operating system, and I installed this container engine. Which is Docker, which is the Docker desktop that is running on my laptop. These three boxes are already there. So now what I can do, I can create any binaries and create container images. And I can give this container image to anyone, and they can also install it on their machine very, very quickly. So now, first going with basics, I think if Docker is installed, so what you can see what are the images that are there in my machine first. Okay, it's all clean. So I don't have any images in my Docker images are there. So Docker images ls is gives the list of images. So but now what I'm doing is I'm going to run this Docker run hello world. Hello world is a ready-made container image. So even for example your application could be here, like could be let's say a .NET or Java application. You can create an image and you can give this image to anyone. So this image, hello world image is a global library that is already available, which is coming pre-installed with Docker. So you could directly run. If you see here, I'm running this container image. Hello world is a container image which is already pre-installed. I'm going to just run it. So I'm just showing the practicals, and then we'll go to the Docker architecture so that you understand this better. So I'm just running this command. So it tried, if you see here, it's unable to find this image, hello world latest. The latest is a tag. So maximize this. Yeah. So it couldn't find this image locally. First it will check whether this image is already there in my local. If it is already there in my local, it will not download it again. So it is not there. So that's why I saw this Docker image ls, which is empty. It didn't return any results. So that's why it couldn't also find it in locally. Then it started pulling or downloading this from the Docker hub. So I didn't give anything because by default this image is already there in the Docker hub. So that's why it is already pulling it from the Docker hub. So it downloaded that image and finally it says downloaded and also it says hello from Docker. So basically it also ran and gave me a hello command from here. So yeah, so this is what is a hello world Docker image I could directly run on my machine. So you can imagine this hello world as a jar or a library that you are giving to your deployment person. So you just need to give this Docker hello world image, better image to the deployment person, and he will also run the same thing on the server in production or QA, for example. So yeah, this is what you need to give it. Yeah.
Sam, you can actually open a shell on that run hello world thing actually, right?
Yeah.
You can do a -t and then bash actually. That will explain what is like when you get into that, it is actually a different ecosystem altogether. Right?
Correct. Yeah, I have steps coming next. Yeah. So yeah. So what I'm doing is now Alpine is I'm trying to download one more image, which is Alpine is an operating system, very small operating system. It's a Linux operating system. So I'm now installing or downloading an Alpine operating system, and once I install, basically now on Windows, I'm now installing an Alpine Linux software. Like you can imagine that similar to Ubuntu or CentOS or any other operating system, but it's a miniature version of the Linux operating system. So I'm downloading this operating system, Linux operating system now, and now I will go inside this Linux operating system and execute the commands. So that's what I'm doing now. So now again this Alpine is already available in Docker Hub. So it will automatically download it. So I didn't give any tag. So by default it takes the latest tag. See, it is very quick. It installed, it downloaded actually at this point. It just downloaded from docker.io. So this is the website where it is. This image is a public image which is already posted. So it downloaded this image. So if I just do it at this point, it just download the image. So if I just run this Docker images, if I give, so it will tell these are the two Docker images that are already downloaded in my machine. The Alpine is the one which I just downloaded. The Hello World which I downloaded before. Right. So yeah, Docker and Hello World. So these are two images that were downloaded on my machine. So this is a command that you can execute to see the list of images. These are all images, container images Alpine is one container image, hello world is one container image. Okay. So now let's go inside this image. So this is an operating system, right? So I'm moving from Windows to this Alpine Linux operating system. So for that, so Docker run. So I'm running this software. So far I just downloaded it. I didn't run it. So you need to run it. And inside, after running it, I'm executing a Linux command ls-l inside that Linux operating system. Okay. So it ran the Alpine software and it also ran ls-l. This ls is listing all the, it's like dir command in Windows, right? So it lists all the, directories. Same thing equivalent is in the next is ls. So it basically lists the files inside the drive. So if you look at these are all Linux folders, which comes pre-installed inside Alpine. So basically it didn't did a list on my Windows. It did a list on the Linux operating system. So these are all from the Alpine operating system. Okay.
Shyam, one query is like instead of ls minus l, can you do uname minus a?
Yeah.
Yeah.
So
what is this?
So this is the Linux operating system, and it gives your version and also when this Linux was installed, or this and what is the hypervisor? Sorry, this is compute. What is that?
The architecture.
Architecture. Yeah. 64-bit architecture. So it gives the operating system details about this. Right. So again, this command is not. It executes this command on this Alpine Linux operating system, but not on Windows operating system. So basically, I'm now toggling between Windows and Linux because by core, the host operating system. The host and guest is what is commonly called. So the host operating system is Windows, and the guest operating system is Alpine. So I'm toggling between host and guest with this Docker. So that is, you can see the beauty of it now. So I'm installing an OS inside OS, and from outside OS I'm calling an executing command inside OS. So that is the beauty of this Docker software. And the only prerequisite that I need to do is I need to install Docker. That's all. So okay, let's move on. So actually, at this point, what happened? So what happened behind the scenes is basically the command that I gave here, right? The Docker run. This is now my this command line acts as a client. Okay. So this Docker, there are slides to show the Docker architecture, but Docker architecture works on a client server architecture model. Client server is like there is a client who will call the server or who gives instructions to server, and server will understand that and gives a response back to the client. So the client and server will ping pong between each other to get what a client needs. Server will provide it. So that is the same model. So when I ran this command, what happened is this is a client. This command prompt is a client, and using this, I'm giving a CLI command, Docker run, and so this is a client. So the client contacts, when I run this command, client contacts a Docker daemon. So Docker daemon is nothing but a software which is always running. So it is like it's like a system thread. So it will be always running, and it will wait for instructions. So now your client, when you gave some command, the client contacted the Docker daemon, and the Docker daemon, what it does is it checks your local store if the image, like Alpine in this case, is already available or not. So it is not there. So then it first basically downloads it from the Docker store. Okay. Since we issued the Docker pull, so that was a command that we ran earlier. So it basically the download step is not necessary in this case. So basically, if it is not even there, it will first download it. But we already downloaded it in the first step. We already pulled it. So it's already there in my local. It will not download it again. So that is a check that it does. So it checks, for example, in Docker run, I directly ran it. It 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 sees that it is not there, and it automatically downloaded it. If you see here, Docker run I gave, I didn't do a Docker pull. I directly gave Docker run. So then first it will check whether this hello world image is already there in my machine. It is not there because ls is empty. Right? So then it unable to find locally, and then start pulling it. So in the Alpine case, I did a pull first, and then I did a Docker run. So yeah, so either you can do a pull and then use Docker run, or you can directly give Docker run, and it will check if it is not there, it will download it. So that is what the daemon is doing, that checks. Then what daemon is also doing is it creates a container and then runs a container in that container. So it so container inside container is like you can think like container inside a container, where it basically creates a container first, which is Alpine image, and then it runs this command inside that container. For example, it downloaded this container, and it executed this command ls-l in this container. So and then it streams the output, ls-l output, basically the list of our files or the folders that came as an output. So that is what is happening. So basically, Docker client is actually talking to the Docker daemon, and Docker daemon checks it. If it's not there, it will download that image, and then it will execute the command that you gave in addition. So right, so that is this Docker. So now let's go further. So what I'm now doing is I'm going to echo is something any Linux operating system can understand. It will just whatever you give inside echo, it will print it. So just running it. It's the same like whatever you saw ls-l. It will just do an echo here. Okay, so it's just printing hello from Alpine. It's basically this message is coming from Alpine operating system, not from your Windows operating system. Okay. And now yeah, this let's say you wanted to go inside Alpine now. So from Windows, you want to go to Alpine and then execute some commands inside Alpine shell. So then in that case, you have comes something called -IT, interactive terminal. So this is what something you need to give. So and bin has such the SH basically you're asking to open the shell of this Linux operating system. So basically again every command starts with Docker run. So and then -IT is now you're telling to go inside and open a shell of Alpine. So I'm just doing that now. Okay, you see here I'm now this is a command I ran. Now instead of C drive, now I'm not in C drive. I'm in slash, which means I'm in now inside Alpine operating system, not Windows. So I can now also execute the commands like ls-l. Now I'm inside Linux or Alpine operating system. So it gives the same command. I can do the same thing whatever we gave uname -a. So this is the Linux operating system. So you can, so basically now I'm inside Alpine, not Windows, right? So yeah, so this is and I can also say who am I? Mostly it will say the root. Yeah. So who am I? The command in Linux which will tell you who are you, like which is root in my case. So yeah, these are the various commands you can go inside. Let's say you wanted to go to bin. You're inside bin to find the files inside bin folder. So yeah, so basically you are inside Linux now, not Windows. Right? So you can do whatever you want here inside Linux. You can install a software here, do a git clone here, whatever you can do everything. So now I want to come out of Linux to Windows back. I just exit. So basically, I'm toggling between Windows and Linux now. You see, so that is the beauty of this Docker. And let's say this is another command, Docker PS. This will tell you what are the processes that are running. So which are basically the Docker software which are running on my laptop. So the one running on my laptop is Alpine. So that's why I tested this Alpine software. Right. So this is it gives you the list of processes running on your machine. So this is the PS command. Okay, and let's say you're interested to delete everything, all the images. Which I'm not doing it, but this is one command, RMI -F, and then let's say you want to see the Docker images running on my laptop. It is Docker images -A. It tells you these are the Docker images on the laptop, and RM is remove command. So selective remove. So it will remove everything from your image, Docker image. Yeah, I think so. With that, probably I think you got some basic idea of what Docker is. So generally, the workflow this image is bit skewed, but yeah, this is these are workflows that we usually use. Generally, the developer. I didn't show you the Docker file, but I'll show you the Docker file the next session. But what developer does is he creates a Docker file. Let's show this. Maximize this image. Yeah. So the developer will create a Docker file, and then using this Docker file, he will create a Docker image. And the hello world in this case is a Docker image, which I'm pulling it, right. So the hello world is a Docker image, and you put this image in some Docker hub. Docker hub is a repository of all the images. Hello world could be one, project A could be another project C, project B. So various projects, all the images of respective projects, you can post it into some container repository, which is a Docker hub. Docker hub is one option, but there are other options are also there. And so every time so you're storing all your images in some repository, and now every time you want to do you can do a pull. So because the software this container image is already hosted in the Docker hub, so this image is ready. Anyone can do a pull. So I'm doing that's what it is. The Docker pull. It downloaded that image into the staging environment. Let's say same. Let's say another test environment you want to deploy the software. You can again do a Docker pull from Docker hub or any other container registry, and it downloads the same software that is already there. It will pull it into a test environment. So that way, the code that is the container image or a Docker image is the same. You are pulling the same software into various environments, and so that way it works the same way. So that is the flow of Docker. So let's move on to the Docker architecture. So yeah, this is I showed the demo so that you understand the commands. So that way you can understand this architecture now better. As I already mentioned, Docker works on this client server architecture. So the commands that we gave here from the CLI, so Docker build, Docker pull, Docker run. So these are the various commands that we gave from client. So basically, this shell. So this command prompt is a client, acting as a client, and the Docker host is a server. So this is where my Docker software is running. So this is my Docker desktop is already running. So this is acting as a server. So every command that we give, it is all first going to the Docker daemon. So the Docker daemon, so it will check whether this image is already there or not. If it is not there, it will go to registry and pull it. It pulls the image if it is not there, already installed, and then it will run this image. And in this process, it will create various containers, and you can access any container. For example, Alpine is the one which we saw. We could go inside this container, and we could execute the ls commands or any other commands inside this container. So basically, so that's how this all works. So basically, client gives the command. Docker daemon will check whether this image is first already there. If it is not there, it will first download it, and once you have the image downloaded, now you can execute, create a container out of this, and then you can do operations on it. So that is the flow. Right. So and everything, the Docker daemon is something that we're using CLI, which is the most popular way, but you can also use APIs. So behind the scenes, these commands are internally using APIs. They're executing Docker APIs. So yeah, so basically this Docker daemon will primarily listen for the Docker API requests and also manages the Docker objects. So it also manages the images and containers. And the Docker client is for what your the user interaction to Docker software. So this is the client, and the Docker registry is where it stores all the popular Docker images. If it is not there, it will download it from the Docker registry, and then Docker objects are where your images and containers, where it will download the image, create a container, and then execute the commands inside the container. So these are terminologies that you need to know. So image, container, registry, Docker daemon, and a client. So this is these are the command. These are the terminologies that you need to know for Docker. Any questions? Okay, so probably I will stop here. I think there are other few slides are there. No, actually we are going into Kubernetes. So yeah, so basically we have Docker software now. So what we saw is we basically downloaded a Docker image, and yeah, we could execute the commands inside the Docker image. But imagine a microservices-based architecture, or your enterprise is having so many projects, and each project is having their own containers. Suddenly, managing these containers will become complex, and especially there could be a dependency between the containers also. For example, let's say yours is a detail architecture. So you have a UI layer, and there is a API layer, and there is a database layer. So when you want to start your software, first time let's say you're deploying your code into production, so you need to deploy all these three. But first thing is you have sequence. You want to first download the image of the database, let's say MySQL. You want to download the MySQL Docker image first, run it, then install your API, your Java .NET code image, and then once that is working, then you install your Angular or a UI, some React-based UI layer. So you want to there's a sequence that you want to see: first database, and then backend APIs, and then your UI. So you're creating a dependency here in terms of containers. So so managing that orchestrating the containers flow is suddenly becoming complex, especially when you talk more in microservices. It will be like there will be so many small services that will be running, and also if you are even not microservices, it's just monolithic. Even if you take the same the concept that I just explained, the 3-layer architecture, you are already seeing a dependency where database should be first, and then API, and then the UI. So that sequencing applies there. So so managing that sequence, we can do it without. We have to follow a framework, and we should do this in proper sequence. We can do it, but it's all becoming very manual. So is there any software that can manage this flow in a better way? The answer is a container orchestrator. So what we're looking at is a container orchestrator, where it can solve the common problems that we have. Like the one problem that we saw is like the managing the sequence. Like how do I manage the sequence? There are multiple microservices and libraries in my application, and each one is a container. It's a you have e-commerce application. Let's say your application is a microservice architecture. There will be a ordering would be one. There could be product catalog could be one microservice. There will be so many microservices that will be there, and each microservice is a container. You can imagine. So then and there will be a sequence of steps that has to be deployed So in that case, how to manage that sequence. So that is one problem, and also how to coordinate these containers, like how, the sequence, right? I mean, first this one, next this one. How will you coordinate it, and how will you ensure that let's say your one of the sequence step fails, the next sequence shouldn't start. So let's say you have such rules, then how will you coordinate it? So suddenly it becomes complex, right? So and also how do you schedule the containers deployment? And let's say you want to schedule it, saying that at this time this has to be deployed and this time this has to be deployed. So you want to schedule the deployment. Then again, yeah, Docker will not solve is not solving the problem. Docker is giving you the container concept, but if there are multiple containers, it comes with some additional problems to manage it. And also how to seamlessly upgrade an application without any interruptions of services. So let's say you're already having a Docker image running of version 1.0 of your container image is running, and you have a new additions you made an upgrade. Now you want to release 2.0. So how will you ensure that 2.0 is not interrupting your existing 1.0? How how will you ensure that this upgrade is seamless? Um, and also how do you monitor the health of your application? How do you monitor health of your container? Because container can anytime, just like in your software, container also can go down because of the limitation of system resources, or it could be your software is not running properly, or you have some bug in the code, so it could die down. So how do you monitor the health of the container, and also how to restart if something goes wrong, right? So these are the common problems that we have. You have container, but it all comes with additional problems when you have many containers to manage. So the answer to all these problems is the answer is container orchestration tool. What we're looking is a container orchestration tool, which can solve all this multiple container coming together problems. So basically, we're looking for a software, a container orchestration tool, which automates this process of deploying, scaling, and managing your container softwares on a group of servers. The answer for that, we have a lot of options available in the market. Container orchestration tools. Kubernetes is one popular orchestration tool. And also, it's not just Kubernetes, we have other equivalents for Kubernetes, which is called Docker Swarm. And also something called Apache Mesos Marathon. So these are alternatives to Kubernetes. But still, Kubernetes is become so popular and it is widely used. But always there is an alternative for Kubernetes. Just keep this in mind. Many organizations still use Docker Swarm as their orchestration tool still. This is also getting consolidated towards Kubernetes nowadays. But yeah, we have alternatives to Kubernetes. Just keep this in mind. Similarly, same thing what we saw in the first slide. We have alternatives to container engines also. Docker is just one, so there are other alternatives to Docker also. Similarly, container orchestration, Kubernetes is not just one. We have other alternatives. Yeah. Okay, so I think now actually we are entering into Kubernetes, but I will logically pause it here.
Yeah.
So I will want to give some time for
It's a good
money.
presentation.
Shyam, can I ask a question here?
Yeah, sure, please.
Yeah. Okay. So when it comes to this container orchestration, because I keep hearing there are some challenges, especially with database scripts and DDL scripts, and then anything because in the microservices architecture there is not any sync up is happening, and always been a challenge with TBAs and everything. So from your real life experience from Srini and you or others, so what is the approach they take exactly to sync up all the environment, meaning all these layers in syncing up and then installing it in different environments? Because I heard that from many people this has been a challenge, but there is no definite solution. But is it correct, or is there a approach?
So Mani, what the so far that 1 hour what we learned is
Yeah.
uh, the way of monolith is kind of trying to diminish, and more small services are trying to thrive up.
Okay.
Right, so that the reason is each one can be doing all these things. It can able to do the different. So can you go to the previous slide? Yeah. No, just remember between the what are all the different advantages of
Yeah, this one.
containerized.
Yeah,
Last
this one.
slide, I think.
Yeah, this one.
Last but before.
This is container advantages.
Yeah, not the container. So what I was trying to say is when it comes to microservices thing, what so you will have different versions of the microservices running, and you want to swap between the different version, and you want to, since a microservice by itself can do magic, I want to schedule it sometimes, and I want to user interact with sometime. So I also want to monitor each microservices. Previously, it is like when we came out with the offer management solution, um, the componentization is not a new thing, right? The componentization was there in 98 or 99 when we started the project. We use a methodology called the catalysis. So even though in those times object orientation and coming out with UML modeling and so on, people were trying to talk about, yeah, UML is good, but I want to create the component boundary. I want to create the clear component boundary. One of the classic component boundaries, UI and API and the data, and sometimes rules. So those are all the component boundary. But the problem with that is still a techno boundary. Can you have a functional boundary, right? Functional boundary is called, for example, when I try to come out with a CRM solution, a CRM will have the UI layer, but it will also need to have a product data. So the metadata is called offer management. So when you have an order management system, order management need offers for it. Offer management itself is a huge component. So it is like peeling the onion when you try to come out with a given a problem, how to slice it out functionally. So now so now what this microservices is giving us is, okay, within the offer management, do you have a product related things? Do you have a offer related things? Do you have a uh, upsell related things? So so functionally dissecting was there a long time, but within a functional dissection, can I still dissect it more functionally, so that 4 or 5 people, 3 to 5 people can manage the whole thing.
Right.
um, and so one more interesting thing is database schema, right? Database
Right.
schema
Right.
was there for the whole offer management.
Okay.
Now they are talking, can you have a separate schema for the products within the product related thing? So so it is more and more slicing the thing so that it could be managed better. The concepts are all good, but when you have so much slicing, it gives the challenge. That's what you're saying.
Right.
So in your case, when you have microservices, giving autonomy to the team, they could create their own versions of the software at their own thing, and the clients can consume based on their needs much
Right.
easier way.
Right.
And each of them will have their own schema. That is the beauty. So this is a new paradigm.
Right.
Previously, offer management is a schema, and that is where it stopped. So offer management, af- but now within the offer management, I wanted to slice it to the product catalog sides of it, and the upsell rules sides of it. So when you do that, what's going to happen is, in relational database schema, we have the primary key, foreign key, which kind of makes sure you have a consistent data across. The consistency is not being challenged.
Hmm.
But now, with the microservice architecture, what they are trying to say is, you slice your own database within your miniature component, and somehow you manage the consistency. So it is little tougher,
Right.
but at what cost? The cost is maintaining the consistency. But what you are gaining by it? You get the autonomy of it. right? So yeah, so this is kind of the whole IT world is very good because we create our own problem, and when we get bored, we create our new problem, and that is what we are trying to do now. So we are getting some benefits out of these microservices, but the microservices giving the ripple effect of whatever the the data in the data world, especially when you slice your data into miniature things. How do you maintain the consistency between one-to-many relationships? When you slice it between, there is an opportunity, it can go little thing, but you still can maintain it. Yeah, so I don't think the containers are kind of giving you that, but it is a ripple effect of the pattern. See, containers you can do for the monolith also, like all the IBM products.
Right.
Now they're all containerized, right? I don't
Right.
think they are not doing so much of microservices yet, because microservices takes time to do. So you could use the Docker for the monolith also, and coming out with the layer, you still have the benefit of the Docker.
Right.
But you really want to get the real benefit of this overall pattern, then Docker is one way, but you have to come out with the design of the microservices, and data data is a challenge while doing.
Okay. Yeah.
There is no
Thank you.
medicine yet.
Yeah.
So
Yeah. Because
that
in the
is where
monolith, actually, we
they
have
need
a better
you, right?
control, as you said. Yeah.
Yeah, that is why they need you and me, the paid
Of
consultants.
course. Of course. Okay. Thank you. Thank you for it.
No, so, Mani, what was your question? Like, your question was
Yeah,
like you
the
had
question,
challenges with
yeah,
database,
the
right?
question was actually what they're doing is because the DBA they operate in their independent and then they give, they keep changing the schema on their own. There is no control to enforce it, and so when they go for deployment, they give a backpack file something like this for restoring it to the each environment, and there is no automated way to doing it. Actually, that's what they were highlighting in one of the customers. So basically they operated independently. The codes are not synced up in a code repository, especially from the database.
But the things are changing now. Now what's happening is, with the cloud native databases, the database is also GitHub friendly. The database is also having the remember, in any software development, the traceability was there, but it wasn't there on the data side of it. Now they're extending the infrastructure as automation tools like Terraform.
Mm.
The Terraform is a module where you could able to. It's basically, if you want to create your own VPCs and EC2 machine and whatnot, you could able to do. That was the primary purpose of the Terraform. But now the Terraform also supports to create your own database schemas and modules within that, copy the data between back and forth, so that as automation, things are all evolving. The Snowflake or the new things are all, what it forces, data was handled separately before. Oh, I don't know. Yeah, it's kind of somebody said they know kind of a thing, but slowly that is coming down. It's all going to the DevOps world of the data.
Oh, okay. So you're saying actually Terraform now it is offering not only IaaS probably, and then it is having, it is offering platform as a service also, right?
Yeah.
That's what they.
So
Okay.
yeah. So the things are, some of these are open source things. So
Okay.
people are trying to come out on their own plugins for those kind of things, and that is what is the traction now.
Oh, I see. Okay.
Yeah.
Thank you.
So, Mani, so
Yeah.
I think your problem is not software or technology. Your problem is management. The DBAs are functioning.
Come
So
on,
I'll tell you.
no, I was a
Yeah,
DBA too, man.
don't take offense. Maybe you were a wild west guy, keep shooting from the hip, but 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 I am just saying that is it looks like, so any technology can only help you. Now it cannot
Right.
discipline
Correct.
you, right?
Correct.
So
Correct. Correct.
basically, so it looks like, so underlying is you need to understand all this technology stack and you should use it to the best actually.
Right.
And if you
right.
say like I will do it the way I used to do and the technology has to adapt to me, that is like it's a little tough actually. So then we have an attitude problem or a personality problem, right? Like, so that's the difference.
Yeah, there are two things here. First, I think we need to understand, how we can use technology effectively to provide a solution here. So that is one part actually I'm trying to, and then also there is a political landscape for that. So political, for that, to a twist to that. But definitely I hear your point, but I'm not going there. But I'm trying to understand, is there any offerings from the technology point of view, and then if yes, actually, how do we implement it? Sorry.
Yes. So I know a solution, right? Like, so this is the typical thing, right? Like in development world or any IT world, right? So you want to start some new application and you go to the database and say, give me this. They'll give you a questionnaire saying how much space you need, how many hours of this you need, and all those things, right? Like you have to fill up all that. They'll create that. It will be 2 months before you get the actual data thing done. Okay, maybe it means it's an extreme case, but I'm just saying like it's going to take some time.
Right.
So when they moved to this container world, they came up with this called database on demand, which means like you don't wait for it, just like cloud, right? Like where you go and say, okay, I want a new server. Yeah, they create a VM server, right? They did the same thing with database on demand, which saying I want a new MariaDB or maybe Postgres, they'll give you actually. And it behind the scenes, it was a Kubernetes solution, which will containerize the entire database for you. So it can run in a fault tolerant manner. Basically you won't lose any service at all, right? Like there will be at least 3 or 4 nodes running of the same, and it is at the container level, right? Like what they are doing is they are running the same database in 2 or 3 flows on the Kubernetes will automatically Kubernetes or the layer above. It's called Demonti. You can look it up. Demonti is one of the solutions that we had actually. They will replicate the data. They'll keep everything in sync. So you don't see, it's like a virtual cloud for you. You get the database within 1 hour, you can get a database up and running. But the downside is the application team has to manage the entire schema they want to do it on there. It's basically saying, okay, take here, you have your own database server. That's it. You can go and manage, you do whatever you want, right? And that's it. Like, so that's so the downside to that is now the DBAs won't come saying like the war space is full now. No, you got to go and do it yourself. That's the flip side of it, right? But you got your own database server. So there is solutions to that. Like Diamante is one of them, right? Like so, for example, our client-facing portal, right? Like UI rbc.com, they started using this basically on the behind the scenes. They said, okay, we will manage our own database, will give me that actually, and it has to be fault tolerant. That's one of the success stories we had, like with regards to Kubernetes or the new containerized environment. But that's the thing actually. So then it's on the application team or like the development team, which they have to maintain the whole schema, the data behind it, the reference data, all the day-to-day runtime data, and you have to pretty much manage what you need to purge and what you need to keep. So that is like your DBA function comes to the development team. That's the new solution actually. That is out there.
I see. Okay, thank you. So you work for RBC, is it? Sorry.
Yes.
Oh, okay. My son is also working for RBC.
Oh, okay, good.
Yeah, he's in the Toronto office. He's working for TA, Technology Infrastructure, as a financial analyst. Thank you.
So, Mani, do you want to talk about your exam thing? What you covered now or later?
Absolutely. I mean, if you want, probably we still have 15 minutes. I can talk about it. If you want, we can push it.
15 minutes. Yeah, we can wrap it up. Yeah.
Okay, Shyam, do you want to pass the control to me? Probably.
Yeah, sure. Yes. So stop presenting. Yes. we have control.
Yeah, can you see this now?
Yes, I could.
Yes.
Oh, okay. Yeah, thank you. I mean, so the next 15 minutes, actually, I'd like to go about, what is the approach I took for getting, what are the offerings by Microsoft from the data point of view, data certification point of view, and then, and then also what is the offering currently as of today, and what are the changes it's taking, because Microsoft is keep changing the data certifications pretty frequently. So that's what my from the next 15 minutes talk about. So currently, actually, the offerings is DP 900, DP 100, DP 200, and 201 on a high level. So DP 900 is kind of Azure Data Fundamentals, and DP 100 is Azure Data Scientist. And then DP 200 and 201, you need to write both the exams to get the data engineering certification. So I wrote all the DP 900, 200, and 201. I didn't take up the DP at 100 actually, because my forte is more of around data, Azure data. For DP 100, actually, those who are interested in Azure Data Scientist, actually, I would recommend to go for AA 100 and then go with DP 100 after that. So the approach is currently, probably I would start with my experience. Actually, I took DP 200 directly. First time, actually, I couldn't get through because I didn't. I got a decent, probably the mark to pass is 700 out of 1,000. So I got like 695, pretty close. But I took up the DP 900 first, and then again I took the DP 200 and 201. I was able to pass it pretty comfortably with good marks. So I would strongly recommend DP 900. Why? The reason is I think Azure data certification is completely different from AWS. I think probably Sham knows it. The reason is in Azure data certification, there are a lot of case studies we need to take up. So that for case studies is covered under 200 and 201. But DP 900 gives the pattern, gives the what you call the glimpse of Azure certification, which is completely different from AWS, because in some of the questions in the 200 and 201, once you answer like 15 questions out of 445 questions, once you answer them, you cannot go and revisit or review them. That is kind of so you need to have a different strategy in answering those questions actually. It's a 3 hour questions. There are 3 hour questions out of and you need to answer. So in total, you'll have typically 45 questions. For DP 900, it will be 60 questions, and the mark to pass is 700. So let me start with 900. I think I strongly recommend people who want to get certified in as a data engineer. DP 900 is targeted, those who want to start working with the data on cloud, because my passion is towards data, and I was an architect to in Accenture in BA and DW space, but so that's why I stick with the data. And it covers basically all the data fundamentals, all the data concepts, relational data, non-relational, like Cosmos. So basically you get to know all the jargons, whatever they use it on the Azure space, which gives you a overall, how the Azure landscape is designed, and you get to, familiar with, everything. So this is lays kind of a foundation for your, 200 and 201. But there is a twist to 200 and 201. As of I think yesterday, I believe, Microsoft has announced 200 and 201 will be deprecated by um, June, and they are coming up with 203. I will talk about that also. Probably before I go, is there any other questions?
So
Yeah,
is there any practical? I also took the Azure that architect exam. So
Okay.
I took the exam. before they changed it. So in that time, I think in the first exam there was a lab where you have to go and do it.
Right.
So do you have something like this here or no?
A lab, yeah, exactly. You take the case study. That's what I said.
Not the case study. What I'm saying is,
Yeah,
case study means they give you the story
yeah,
and you have to answer it. That's what the case study, right? What I'm referring is more like go and do it in the. This is what my scenario. Do
right.
it in the Azure lab itself. They give you the environment. You have to
I
go and
see.
do it, and
Okay.
they, yeah. So it will be your practical thing also will be evaluated along with your theory. Do
Right,
you have
right.
something like that?
But here it is not actually. But the questions actually is this is what actually my experience is. I think that's a very good point. I what you raised, because as I said earlier, when I took up this 200 exam, initially without taking the DP 900, I was not doing a lot of practicals. But one thing I will strongly recommend is I have my own account, and I of course I use my credit card for that. Because I spend like I monitor my spending $100 per month, so I prepared like two months for that. But as you said, actually they provide you a lot of screenshots, but it is not a lab. But they take you a lot of screenshots and ask questions from the screenshots. So if you don't have a practical knowledge, you will not be able to answer. For example, if you go to this labs and then if you go through the questions, uh, of course, 30 to 40% of the questions appear from there. But at the end of the day, certification only not only will help you to get a job actually, and you need to do a lot of practicals. So I would say there is no lab actually, as you said, but there are a lot of screenshots. They use it from the Azure portal to there are questions around that using the screenshot actually. So
Okay.
yeah, because if you don't do any practical, I mean, if you don't create, for example, a data factory and then do a data orchestration or ETL pipeline, from source to target, from unstructured to structured, and data bricks and everything, it is very difficult actually. So
So
okay.
is this takes you to the data engineering side of data scientist? What is?
No, actually, it gives you kind of some idea. That is what actually what I covered actually probably in the called the data bricks. It's a Spark based analytical platform where you can. This is what you will be using it for your AI modeling and everything. So this is actually is part of 200 and 201. So that definitely gives you a foundation. But as I said, actually, there is a separate course for that, actually, which is I think it is called VP100 and AA100.
Okay.
Yeah, because I wanted to be a data engineer. That's what I am right now actually, and because this is a good story actually, because I've been in this cloud for a long time, but not really doing a lot of hands-on. But after joining this group, of course, I got my AWS certification that induced me a lot of interest in the cloud space, because I've been in this IT space for more than 30 years. But because to be with the technology and this one, definitely, after joining this group, it's a big inspiration for me. And you, Sham, and probably Raj, Jnanesh, Bala. I mean, Venkatesh has been a big strength, because what I did is, I think the approach what I took was I peered I did a kind of peering group with Venkatesh and other Murli and other guy Pradeep. So we started kind of a group, as you suggested. We kind of meet 2 days a week in the evenings, and then do a lot of practicals, a lot of practice. That helped me. That is the key to success, I think so. So they are from very strong cloud background. We exchange our ideas almost on a daily basis, and we bring up the daily problems actually, and then we try to solution that. That helped me, because of course the cost is the one thing we need to watch, but that's fine actually, but
Yeah,
initially,
I
but
think
yeah.
it's an investment, man. Don't say it as cost.
That's true. That is true. Yeah, exactly. I agree with you. It is an investment. Probably that's a good correction. So yeah, it is. I think it is. It is. I think you guys have a big inspiration. I think so. Cham and Srini, and Jnanesh and Raj. I mean Bala, Venkatesh. So many people I need to name. I think that's been very. I think that's it actually. But probably this is what actually I said. DP203, they have come up with now deprecated 200 and 201 by June, but 203 there is a good twist now. So what they are saying is in 203 they are insisting you need to have a SQL, Python, Scala, but it is, of course, I learned that too in Databricks as part of it. Without that, actually, there's no, I mean, you'll not get any jobs, but there are not many questions in 201 around SQL, Python, and Scala, because it is more around, what do you call data storage, data processing, real and architecture, and everything. But this one is a big one, actually, I would say. They are coming up with, actually. So, but only thing is, I mean, probably Sham, you might know better, because I was told when you say data, when you'll not get the result instantly, you may have to wait till June to get certification. Is that true?
Yeah, that's true. I think all beta exams will take 3 to 6 months, mostly 3 months max. But yeah, I think you will not get the results also immediately. You don't pass or fail, but you will not get the result immediately.
Oh, okay. I mean, that's why actually Venkatesh is already taken 200, and I think he's writing 201. I think today or tomorrow probably. That's why he didn't join today, because they're going to deprecate everything by June. Until then, you automatically qualify for 203. That's one more thing. So that's what they announced it.
So what is the prerequisite for 203?
Sorry.
Do you have a prerequisite certification for 203?
There is no prerequisite.
Okay.
Yeah, you can directly take up. Yeah, because this is what actually, when I say TP900 and DP900 is just a foundation, but you can take up 200, 201 even now as of today, because it is that the exams are available as of, because in order to get data engineering certification, you need to take up 2 exams, 200 and 201. But as of yesterday, they are just combined both into one exam. But of course, the results will be out only by June if you take up the exam.
So by 203, you will be a data engineering, but also you are focused on the Scala, Python, those kind of things
Correct,
with the new, right?
correct.
So no need of 2 exams, it's going to be only 1 exam.
Correct, that is right.
And also no prerequisite, directly you can.
No prerequisite, yeah.
So yeah, so if possible, what I would suggest is, if you have some time,
Yeah.
why don't you put together the technical side of all the 3 exams? What it takes to do, what are the things it covered? What is the things tying technically between the 1 and 2 and 3 certification? See, we don't care whether it's deprecating or not. We just want to use that to learn the track, right?
Sure. Yeah, that's why actually probably I just put some Databricks. What is Databricks is. So probably I will cover, actually probably we are already run out of time. I think that's good actually. Probably I will just write about each exams, how many questions are asked, what are the questions, and what are the topics are covered, and probably the resources I used it. I used WizLabs, and then I used there is a I think exam topics. I think it's a free site. I think Cham, you recommended me. I think so for AWS. That is
No,
what I used. You did. Okay, I think one of you. I'm pretty sure one of you. So I used exam topics, WizLabs, and
money. So that is good, but
yeah.
this whole field is kind of, if you think about, right, the data
Right.
is more proprietary, right? Data in AWS doesn't translate into Azure, similar to GCP, correct? So what you could articulate is, see, there is a Databricks, there is a data factory, there is a Cosmos DBs, and they have their own blob storage and they have the file system storage and whatnot, right? So what I want you to think through is how so now you kind of know the different compartments within the Azure side of the data, and how that is being coined, uh, how that is being which test is giving more emphasis on which side of the technology, and what it takes, how it's, that is what is confusing for many people, right? They each one, they have their own things and they deprecate the system and so on. Now there is a new exam, but I don't care about the number of exams. What I want to know is the learning side of
Yeah, definitely. Actually, because definitely what you're saying is actually, let me summarize it. You're saying, what are the skills required for the certification from the exam point of view. So basically, if you take 200, you're talking about data storage solutions, data processing, and then a real-time batch processing architecture, data security, compliances. Yeah, definitely. I can put some.
together more and more details, like
Right.
whatever right, the more you put, that is going to be helpful for you also, right?
Of course, of course, of course.
And that is what is going to give you the command. If you get a real job, right,
Right.
certification is one thing, but you
In
have
fact, actually, that's what I'm saying. I switched the job because after getting certification, actually, it helped me to switch my job because currently, as of today, I switched my job like immediately after getting a certification. I got a job from what they call Tommy Hilfiger. That's where I'm working now, and
more good.
yeah.
Congratulations.
Thank you. So that helped me actually, so definitely, I'm a probably example for that. And, I'm happy to, I think what your point, yeah, definitely I'll try to put more, probably more slides actually, from the architecture consideration, all the reference security consideration and scalability, everything, and then exam point of view. Yeah, definitely. Yeah, definitely. It helps me also to understand. And then also I'm looking forward to Sham's, Kubernetes. And Sham, my request is probably if you can give me an example from CI/CD point of view, how Docker Kubernetes, can be, used it along with the Azure repos. That'll be a great help for me.
Good.
Yeah,
Yeah,
thank
I
you.
think that is in the roadmap. So yeah, congratulations first of all. And what the whole purpose of this group is, introducing the technology and more support and talking. Each one of us will motivate each other, right? And we have to see many people got certified, but certification to the job is the next milestone. So you achieve that. So yeah, so now you can drive on the data side and try to see uh, more and more content. And if you could able to do it at least if not every week, every other week, go a little deep dive on each one of those things and put more content so that we all can understand
Yeah, sure.
it. Okay,
Okay, thank you.
sounds good. Yeah, thanks, man. Yeah, Sham, anything from your side?
I think it's really good. I think congratulations on the certifications and also the new job. So it's really encouraging for the group and also motivates everyone. So and also this like just to add to what Srini said, I think uh, the data side is one of the most popular on-demand technologies, and data I mean any organization now, like data is the oil, right? So it is, I think it's good to have the data skills. Always helps, and there is an actual data engineering and the progression is more towards the ML and data scientists, right? So that but most of the jobs in the AI/ML space is there, but the prerequisite for AI/ML is data engineering. So unless you have data engineering skill, it is difficult to gain knowledge to understand how the data looks, and what are the various sources and what tools we have from Azure. So I think the data area is very huge in all the cloud areas. So and Azure is also the dominant space. yeah, even though they came late in this game of data side, but I think they really spearheaded very quickly to compete with other cloud vendors in this data space. So yeah, I think
Uh,
yeah, good to have this
yeah, my
knowledge
only
sharing
yeah,
data
so
side.
my only recommendation is each one of us should pick one of the data area and SME on that area. For example, Azure or AWS or GCP first, because that itself is a lot and lot of effort required. Um, See, getting the general architect certification is different because compute, network, storage, security is all four pillar for across, because that is universe. But data is implementation of data is each one is diverse still. Yeah, that is why this, even though I know a little bit on the AWS side, now Money knows a little bit on the data Azure side. The more we talk it out and so on, I might not take a Azure data certification immediately, but knowledge is the power, right? So that is what we bring the point, and hopefully, if somebody wants to get into the Azure of the data specialist thing, Money is going forward. Classes could help.
Thank you. Sure.
Okay. Yeah, I think we have done a good chat today. Anything else, Sham, or we can wind up?
I think we're good. I think we can kind of so
Okay. Yeah, it was a good session
good
overall.
session.
Thanks. We'll meet again.
Yeah.
Thanks, everyone.
Thank you. Bye.
Bye.
Bye all.
Yeah, thank you.